Okay, so in this video, we're going to start Unit 5, which is called Solutions. And we're actually going to start the notes with 5.1, which talks about solubility. Okay, so we're going to be talking about solutions, and specifically, we're going to be talking about solubility, and then we'll continue talking about different types of solutions throughout Unit 5. Okay, so the overall unit is about solutions, like I just said, and just because this whole unit is about solutions, before we get to explain what solubility is, let's talk about what a solution is. Okay, so a solution, this is just kind of like the definition of a solution. It says a solution is a homogeneous mixture. Okay, remember, homogeneous mixture, when we see that term homogeneous, that means we have a mixture of things that are mixed together so that we cannot see the separate pieces. Okay, so a solution is a homogeneous mixture of at least two different substances, and now we have some vocabulary terms, the solute is dissolved into the solvent. Okay, and so before I talk about solutes dissolved in solvent, let me go back to the homogeneous mixture thing. Okay, so remember in a homogeneous mixture, the things are mixed together and you can't see the different pieces, even though it's made of two different substances, they're blended together evenly. Okay, and so for example, you could not like look at a solution and see the different pieces blended together. Okay, so for example, salt water is an example of a solution because if you put salt into water and you stir it up, it blends together really well. You can't see the difference between the salt and the water. Whereas if you took like, say, rocks, if you put rocks in a cup of water, then you would just have, rocks and water, and you could see the difference between the two because rocks are not going to dissolve into water. Okay, and so let's talk about what these vocabulary terms means. Okay, so it says it's a solution where a solution is a homogeneous mixture of at least two different substances where the solute is dissolved into the solvent. Okay, so what do I mean by solute? Okay, so solute is whatever it is that is being dissolved. Okay, and so a lot of the time when you talk about solutions, you're talking about something being dissolved into water. And so in the example I gave before, where you put salt into water, the salt would be the solute. Okay, that is the thing that is being dissolved. The thing that is doing the dissolving is called the solvent. Okay, so every single solution has a solute and a solvent. Okay, you have the thing that is being dissolved and the thing that is doing the dissolving. Now, a lot of the time, the solvent in most solutions is water. Okay, not always, but most solutions it's water. If it's not water, the way you can tell which one is the solvent is it's usually the one that's present in a greater amount. Okay, so whichever one you have more of when you mix them together, that one is usually the solvent. Okay, unless the solvent is water, and honestly, in most solutions, the solvent is water because usually you're putting stuff into water and you're mixing it together to make your solution. Okay, so you have the solute and you have the solvent. Okay, and then this is just a simple example of a solution. If you pour a cup of salt into water and you stir it, the salt would be the solute because that is what is being dissolved, and the thing doing the dissolving is the water, and so the water would be the solvent. And again, one of the most common solvents is water. Okay, so a lot of the solutions we'll talk about, the solvent is water. Okay, so that's basically what a solution is. All right, so make sure you have all of this filled out in your notes, and then we will move on to the next slide. Okay, so sorry, I had a little technology issue there. So let's talk more about dissolving. What do I mean by dissolving? Okay, so I talked about mixing a solute with a solvent, and the solute is the thing that dissolves, and the solvent is the thing doing the dissolving. But what does dissolving actually look like? Okay, so that's what we're going to take a look at now. Okay, so basically, the way dissolving works is something like this. The process of dissolving is called solvation. Okay, not salvation, solvation. And basically what happens is if you think of the atoms and you think of the molecules and the solute and the solvent, um, if you look at this picture here, remember that the most common solvent is water. And so in the picture here, you can see the water molecules and the solvent molecules are attracted to the solute. And so in the picture, you can see the water molecules kind of like group up around the the solute, which in this case is salt. It's a lithium chloride. And then what happens is these solvent particles surround the solute particles and basically pull them apart into a solution. And so here in the picture, you can see basically you start off with this lithium chloride, which is the solute. The water molecules, the solvent molecules surround those atoms, and then they basically pull them apart. And I'm going to link a video in so you can see what dissolving actually looks like. But basically, the solvent molecules pull apart the solute molecules, and then you get a solution. Okay, so everything just kind of gets pulled apart, basically. Okay, so check out that video. Okay, so now that we have a better idea of what dissolving means, let's just kind of review solute and solvent. Remember, the solute dissolves into the solvent. Here in this slide, you can just see like a picture of what we've been talking about, where salt is the solute, water is the solvent. Okay, meaning this is the thing doing the dissolving. This is what's going to dissolve. And so when we mix the two, we get a solution. Okay, so every single solution has a solvent and a solute. Okay, and then these are just some pictures showing those words again. Okay, so now that we know what a solution is, right? A solution has a solute, it has a solvent, it's a homogeneous mixture. The most common solvent is water, but not always. Now we can get a little more focused in this set of notes and talk about something called solubility. Okay, and so when we talk about a solution, we're talking about a solute that is dissolved into a solvent. And some things dissolve easier than other things. Right? And so the way that we measure how well or how easily a solute can dissolve into a solvent is with what's called solubility. Okay, so when we talk about solubility, we're basically talking about a number that tells us how easy is it for a solute to dissolve in something. Okay, and so solubility is a physical property. Okay, it's not a chemical property, and it basically again describes the solute in a solution. How easily does that solute dissolve in that specific solvent? Okay, specifically, this is like the definition of solubility. Solubility is the amount of a substance that can be dissolved in a substance under specified conditions. And over the next few slides, I'll explain exactly what that means. Okay, but again, all solubility is it basically just tells us how easy is it for a solute to dissolve in a solvent. Okay, and it's a number. And as we'll see, it's a number that changes under different conditions. But let's see what that actually looks like on the next slide. Okay, so the way we express solubility is kind of complicated, and this might be kind of hard to see in your notes, so I apologize. But the way solubility is expressed is it is some number, and we don't know the number right now, it depends on what it is, but some number of grams for every 100 grams of water at one specific temperature. Okay, and so every time you look at a solubility, it's going to have these three parts. It's going to have this many grams for 100 grams of water at this specific temperature, this many degrees Celsius. Okay, so here we can see that the solute is here. Okay, so it's however many grams can dissolve. The solvent, when we talk about solubility, we always talk about water being the solvent. Now, water does not have to be the solvent. That's just usually how solubility is expressed. So this part is always going to be the same. And then every time we look at solubility, we're always told the solubility at a specific temperature, right? And the reason we're always told the solubility at a specific temperature is actually what we'll see is the solubility tends to change at different temperatures. And actually, things tend to dissolve easier at higher temperatures. And we'll talk about that more. But just to give you an example of that, I'm thinking of like making like hot chocolate. And hot chocolate, if you stir in the powder and you mix it, mix the chocolate powder into the milk, it's a lot easier to stir in if you actually heat up the milk first and then you stir it in, right? Because then the increased temperature is going to increase the solubility, and it's going to be easy to mix in more chocolate when you heat up the milk first. Okay, so hot chocolate dissolving into milk, that would be an example of a, a solution. In that case, the hot chocolate powder would be the solute, and the milk would be the solvent. But we'll come back and talk more about that later. Okay, so again, what does this actually mean? It means how easy is it for something to dissolve, and how do we find solubility? Like, how do scientists find solubility? Well, usually what they do is they do an experiment. And so in the notes it says we have to test it, and by test it we basically mean do an experiment. So now we're going to talk about how would you actually go about finding the solubility for different solutions. We're not going to do anything where you actually need to do this type of experiment, but you do need to be able to explain how the experiment works. Okay. And so just to kind of like refresh your memory about some things, we talked about this in Unit 1 this semester. So at the very beginning of the semester, we talked about the basics of an experiment. And every single experiment has three different parts. Okay, you have the constants. Okay, those are the things that are always the same, remain the same for all test groups. You have what's called the independent variable, and the independent variable is the one that is controlled by the person doing the experiment. Okay, so the independent one is the one that changes first. Okay, if you think of cause and effect, the independent variable is the cause. Okay, so you have the control variable or the constants that stay the same. You have the thing that the experimenter changes, and then usually when you do an experiment, you change something and then you see how something else changes. And that something else is what we call the dependent variable. Okay, and we call it the dependent variable because it depends on the independent variable. Okay, so if you think of cause and effect, the independent variable is the cause and the dependent variable is the effect. Okay, so what does that have to do with solubility? Okay, we'll make sure you have this in your notes and then we'll go to the next slide. Okay, so if you imagine looking at this solubility thing that we have here, think about which one is the dependent variable, which one is the independent variable, which one is the constant variable. Think about which of these is always the same regardless of what is being tested. Okay, well, every time we talk about solubility, it's always over 100 grams of water. Okay, and that's true no matter what it is. It's always per 100 grams of water. And so that is going to be the constant variable. Okay, and then the way they do the experiment is basically this. Okay, so let's say you have a solution and you're trying to dissolve solute into your solvent, and you do it at one specific temperature, and you find out how many grams can I dissolve into my solvent. And then what you do as the experimenter is you increase the temperature, and then you try to dissolve more solute into the solvent, and then you increase the temperature again, and you try to dissolve more solute into the solvent. And so the variable being manipulated or controlled, when it says in the notes manipulated, that could also be controlled by the experimenter. That is going to be the temperature. And so remember, the one being controlled is the independent variable. Okay, that means this is the dependent variable, the number of grams that actually dissolves, independent. Okay, so to do this experiment, basically you dissolve solute and solvent, you change the temperature, and then you just, dissolve more solute, and and you keep the 100 grams of water constant. Okay, so what happens is, and this is basically just giving you the answer that we just talked about before. If we increase the temperature, most often more solute will dissolve. That's what I said before, where if you increase the temperature, it usually increases the solubility. Okay, so usually, let me write that down. Usually, if you make the temperature bigger, the solubility is also going to get bigger. And again, the easiest way to remember, just think hot chocolate. There's a reason you heat up the milk before you put in the powder. That way you can dissolve more chocolate into the milk. Because otherwise, if you've ever made hot chocolate, then you know what happens. If you dump too much powder in, then it's not going to dissolve, right? Then you just have like powder at the bottom and it like clumps together and it's kind of gross. Okay, and so to be able to dissolve more, you want to heat the milk up first before you put in the powder, right? And so if you increase the temperature of a solution, you're going to increase the solubility usually. All right, so this is basically what I was talking about before. All right, so let's do a simple example. A scientist uses 100 grams of water to test the solubility of sugar. She finds that the solution is saturated by 110 grams of sugar at 25 degrees Celsius. What is the independent variable in this experiment? Okay, so based off of what we just talked about, see if you can answer this question. Okay, so remember, in this type of experiment with solubility, the thing that the scientist is controlling is the temperature. Okay, so temperature is the independent variable. The dependent variable is not even listed here. The dependent variable is actually the solubility. Okay, so the water would be a constant. This doesn't even make sense, and this doesn't even make sense. Okay, so the independent variable is the temperature. Okay, so pause it there, make sure you have that in your notes. Now, if you go back a second, there's a word in here that you might not have recognized, and that word is saturated. Okay, so we're going to talk more about this word right now before we finish up this video. Okay, but it says the solution is saturated. So let's talk about what that means, saturated, because that's an important word in this unit. Okay, so there's different types of solutions, and the first type of solution we're going to talk about is what's called a saturated solution. Okay, and you can read what it says in the notes about a saturated solution here. It says a saturated solution is reached when no more solute can dissolve into a solvent at a given temperature. Okay, so in other words, if you imagine going back to the hot chocolate example, let's say you have a cup of milk and you put just like a little bit of chocolate milk powder into the milk, right? It's all going to dissolve, no problem. And let's say you put a little bit more powder into the milk and it dissolves, okay? And you put a little bit more hot chocolate powder into the milk, and you keep doing that. Well, at some point, it's not going to dissolve anymore, right? Like if you just pour like a ton of powder into the milk, eventually it's just going to like suck up all the milk and it's not going to dissolve at all. So saturated solution is basically when it reaches that limit, right? A saturated solution is reached when no more solute can dissolve. Okay, so that's at the threshold of being like, you could still add more versus now it's not even going to dissolve anymore because it's just going to like stay in its original form. Okay, so a saturated solution is where it's reached its limit. You can't dissolve anything more. And if you're looking at a graph of solubility, these saturated solutions are found on the line. Okay, and so what I mean by that is a lot of the time, and we'll see this in the next lesson, but a lot of the time when we're looking at solubility, we're looking at graphs, and the graphs look something like this. Okay, where there's just like this black line going across the screen. Anything on the line is saturated. Okay, so that's why it says on the graph, these are found on the line. Okay, so everything on the line is saturated. Above the line is going to be supersaturated, and below the line is going to be unsaturated. And we'll talk about what those words mean later on. Now, the other thing I want to tell you is that in order to reach saturation, um, if you increase the amount of water that's being used to prepare the solution, then you also need to increase the solute. Okay, so for just to give you an example, going back to the hot chocolate mix, let's say you put in the chocolate milk powder into the milk until it's saturated. Okay, and let's say you increase the amount of milk in the cup. Let's say you pour it into a bigger cup and then you pour more milk into the cup. Well, now it's not going to be saturated anymore because you added more solvent, right? And so in order to still be saturated, if you add more solvent, you would also have to add more solute, right? Because otherwise what's going to happen is it's going to become like diluted, right? So you could have like the perfect cup of hot chocolate, but if you pour in extra milk, then what's going to happen? It's not going to be saturated anymore. It's going to be unsaturated, and actually it's going to taste like weaker. It's not going to taste as good. Okay, and so that's all this is saying right here, where it's basically just saying if you have more solvent to be saturated, you have to also have more solute, which if you think about it should kind of make sense. Okay, so that is the first type of solution we're going to talk about. That is a saturated solution. Make sure you have that in your notes. Okay, and actually I think we're just really quickly going to talk about supersaturated and unsaturated, and then we'll come back more and talk about it in more detail in the next lesson. Okay, so we have saturated solution. A supersaturated solution is basically one that contains more dissolved solute than a saturated solution. Now, if you look at what it says in the notes, more dissolved solute than a saturated solution. If you think about that carefully, you should be like, wait, how's that even possible? Because remember, a saturated solution is already at its limit, right? Like that's what makes it saturated, is it's already at its limit. It can't dissolve any more. Okay, so a supersaturated solution contains more dissolved solute than a saturated solution. You should be scratching your head at that point, being like, how is that even possible? We'll talk more about that in the next video. But if you're looking at a graph, a supersaturated solution would be above the line. Okay, and then the last thing, just really quickly, is an unsaturated solution. Okay, an unsaturated solution is one where it hasn't reached the limit yet. It contains less dissolved solute than a saturated solution. So going back, and on a graph, it's underneath the line. So going back to the hot chocolate example, remember how like if you just add like a little bit of hot chocolate powder to the milk, that's an unsaturated solution. And you keep adding more and more and more and more, and eventually it reaches a saturated solution when it hits the limit, right? So if it has less um, dissolved solute than a saturated solution, it's unsaturated. Okay, so in other words, the solvent is not yet maxed out. You could still add more stuff into it. You could still dissolve more stuff into that solution, right? That's what an unsaturated solution is. It could still dissolve more stuff if you added more stuff to it, right? And so, and I honestly, I would think like most, like again, going back to the chocolate milk example, because I like chocolate milk and it's good. Most people when they do like hot chocolate or they do chocolate milk, it's probably unsaturated to be honest, because most people probably just like put like a little bit and then they mix it up and they're like, oh, okay, that's good. Most people probably don't take the time to make sure that you actually reach the limit of dissolving, which would be saturated. Okay, and so again, unsaturated just means it you know, it's a solution. You're dissolving a solute into a solvent, but it hasn't reached the limit yet. All right, and we'll talk more about that in the next video. We are going to stop it here, and then next time we'll talk more about saturated, unsaturated, and supersaturated solutions. We'll talk about how do you even get a supersaturated solution, because that seems like it would be impossible to have more stuff dissolved than the limit of dissolving. But we will talk about that in the next video. Okay, so as always, please let me know if you have any questions, and I'll see you guys in the next video.